Good morning, everyone. There we go, sorry about that. Good morning, everyone, and welcome to day 2 of Strategic Farm Results Week, all about managing lower inputs. So I'm Alex Wade, Knowledge Exchange Manager for cereals and oilseeds in the Southeast, and I actually look after and help out with our new strategic farm in the South, David Miller's, who will be on the webinars later this week. But these results today are based off the trials from our strategic farms in the East, at E.J. Barker and Sons, which is managed by Will Smith from NIAB, the West, which is Rob Fox at Leamington Spa, which is managed by Chloe Morgan from ADAS, and Scotland, Strategic Farm Scotland, David Aglin up in Fife, which is managed by SRUC, and Steve Howard will be taking us through those results today. So before we get started, I'm sure you've all seen this slide before, but you're all on mute, but if you have any questions, please add them in the question box on the right hand side of your screen. The webinar is due to finish at 2 o'clock. Basis and Roto points are available, so if you didn't enter your details in on the register page, use the question box on the right hand side. But if you already, as I said, if you've already entered them in on the register page, then don't worry, we'll get those sorted for you. And the webinar is being recorded and will be available on the AHDB website and the YouTube page in the coming days. So for those of you who aren't aware, I'm just going to mention a few words about each strategic farmer, just in case you haven't come across them before. So I'm going to start on the right hand side actually with David Aglin. Now David has hosted the strategic cereal farm in Scotland since September 2020, so this is his sort of first proper set of results and proper year, and with 1,200 hectares of a mixed farm, 800 of which are arable. The key focus areas for David include sort of regenerative agricultural practices, plant and soil health, and reduced inputs. So particularly focusing on the interaction between plant nutrition and soil health versus how much disease is in the crop. So essentially, if you've got a healthy plant, healthy soils, do you have less disease in that crop? And can you wind back those applications? Rob Fox in the middle there, he was the Strategic Farm West host since 2018. So he's arable farming in Leamington Spa, particularly wanted to focus on harnessing the potential of actual varieties to alter those fungicide strategies. So, drilling the correct varieties with the strongest disease rating for whatever's a problem within your area. And then Brian Barker on the left there, he's based in Stowmarket. Having been strategic farmer since 2017, over the years he's been comparing a high input fungicide regime versus a low input fungicide program, and the results from the 2021 season trials will be shown today. Now Brian was going to be with us today, to discuss his results and finding and his thoughts on the trial, but he can't be with us today, understandably, as he's on paternity. So we didn't make him sit through a webinar. However, we did manage to get a video from Brian on his thoughts on the trials, and we'll play that after we've, shown the results from the East. And because of this, if the webinar ends a little bit earlier than 2 o'clock, I'm not going to stretch it out for the sake of stretching it out, but we are flexible depending on the questions that come in. So just to recap, we've got 3 approaches here at looking at reducing inputs. So we've got the nutrition side, making sure the plant's healthy and the soil's healthy. We've got the variety side, just selecting the right varieties, not just the one with the biggest yield. And we've got the high versus low fungicide inputs. And hopefully by pulling all these 3 together, we can get a good managed approach to lowering inputs. So without further ado, I'm going to hand over to Will Smith from NIAB to go through the results at Strategic Farm East.
Okay, so good morning, everybody. So I'm Will Smith, so Senior Trials Manager at NIAB TAG, and I've been managing the work over at Brian's this year. Primarily for me, that's been managing this lower inputs trial, as Alex has excellently introduced. So what we were trying to do at Brian's was it's not changing. It is changing. We're fine. So hopefully some of you have already listened in to some of the earlier webinars where we've talked about this type of trial. We've got a very robust approach where we've looked at across a higher and a lower input level, the T1 application, T2 application, and the T3 application completely independent of each other, and then each of the combinations from those traditional timings put together. So this is enabling us to really break down and look at those timings individually and look at their overall response from each timing really robustly, really thoroughly. But we still kept the replicated sort of field scale trial type work that has been done on Brian's in the previous 2 or 3 seasons. So we're still looking at large field scale trials. We've taken subsamples within the plots, but we are really looking at this large approach. So what do those low and high inputs look like? And really, it was never set out from the beginning what these would actually look like. It was always going to be a very flexible managed approach depending on the season. However, having said that, obviously we need to force things in some places. So the high input levels, they received a sort of pre-T0 a nutrient boost with these sort of epsotop and then these micronutrient packages, yield on and Yarrow product mancozeb. The T1, the key differences really were going from just the Firefly, which is a strobe and an azole package that was in the low. We used Bugle in the high, which is an STHI. And then we topped that up with a little bit of tebuconazole from the fungicide perspective. Moving to the T2, this was sort of mainly fed sort of bulked out by the use of Revistar, so the newer fungicide from BASF, at the lower rate at the low input level, and then at the 1.5 litre rate at the high level, and then again supported with some micronutrient yield on. And then at T3, it was fairly robust even at the low level. We went back and used some more Firefly, so this is the fluoxystrobin and prothioconazole product at a lower rate, and then using a slightly higher rate accompanied by Bridgeway in the high input level. So we're talking about both different products but higher rates and supporting that with additional material as well. So overall, we've got a package that's much higher input level. I think it's really important to sort of put this in context of the season that we had. And this year we had a particularly wet December and January. These are the grey bars is harvest 2021, and working back, green is 2020, and blue is harvest 2019. So yeah, so really wet December, January, moving into a spring that was particularly dry, particularly April. March and April combined were incredibly dry, particularly considering the previous years. And then May was an absolute sort of torrential downpour at Brian's, and you could barely get out of the field on any day without being moderately drenched. And then in terms of temperature, sort of follows the similar pattern, but again with some sort of almost slightly more extreme numbers. Really cold sort of January into the new year, and then even sort of March and April. Yeah, there we've got April again. The grey line is particularly cold for what we've seen in previous years. So we're working with a season that was particularly dry, particularly cold in that spring when we're trying to get diseases entering the crop, trying to get into the crop, and then we're also trying to control it. And that's really why overall we didn't really see a great deal of disease pressure across the entire trial in this year. Septoria was the most common disease, and in the picture on your left, that's the untreated, one of the later assessment timings. So this was sort of amounted to somewhere around 15% Septoria on leaf 1 and leaf 2. We did have some sort of late season yellow rust that came in, really came in from the top of the crop, hadn't worked its way up through the canopy, so it was really isolated on that sort of leaf one. And then we also had quite a severe fusarium infection across areas of the trial. And it's not too surprising, as we said, that was at sort of quite high moisture levels in May, when the ears are just beginning to come out. So it was sort of a surprise to see the fusarium, but it's added nicely to this trial. Overall, there's low disease levels already. The disease control was pretty robust from all the programs, both low and high. And generally, if you put you applied at more than 2 timings, we had really good control. What I really want to talk about really though is the yield and look at how this control translates to yield. And we took 2 approaches at Brian. So we did take our little plot combines out, and we took some strips through the field for each plot. So we've ended up with 4 plots for each trial. For each plot. But we've also compared this with the yield maps from Brian. So we've looked at that closely aligns. So the figures here presented are from the plot combine. So if we look across, these are the crop yields for the entire trial. So, and the bars are the min and max observed across all plots from that treatment and across the replications. So actually on the whole, the crop yield, even in the untreated, yielded extremely well. And on average, this was a little bit above the historic average of the field, which is looked at in other years for that sort of position of winter wheat on the farm. So a really strong base to work from, and possibly not one where we're going to be seeing huge yield responses. But there are some patterns that do tend to come out. Generally disease control, where it was better, we've got the high yield, and this tends to be accompanied, associated with these higher input packages, particularly towards the right-hand side of the graph, where we've got a full program, T1, T2, T3, at either the low or the high input level. I think across the entire trial, it was the highest input level that actually rewarded us the most and gave us the highest yield overall. But it was a fairly close run thing when you split it out between the low and the high programs when averaged across the entire trial. So, as I said at the beginning, one of the nice things about the way we've designed this trial is that we can really look at these yield responses and isolate them. So we can look at the relative performance of each individual timing and break that down. We can look at how we can be flexible around the program. So generally the large responses were associated with higher inputs, most notably sort of at the T1 and the T3 timing, whereas at the T2 timing, there was very little in it. I think that's just mainly down to product choice. We've got a fairly new product from in Revistar, and even at that sort of 0.8 rate that was used as part of the low input, it was more than sufficient activity there in a low disease year. What's quite nice is actually, I think this way of splitting this up demonstrates that in terms of an overall yield response, it shows where we can mix and match, and therefore where we are able to sort of manage our input levels in hindsight through a season. But it gives us some confidence to sort of talk about how this might happen. And in this trial, actually, it'd been more than ample to have mixed, sort of go in with a higher T1 and then drop down and manage that input at the T2 level, and then top it back up with a slightly more robust T3 that was able to deal with both that yellow rust later in the season and the fusarium. When we look at this from sort of like a gross margin perspective, and that's really the important thing that we need to be looking at when we're talking about these lower inputs. And actually, it's not just how they are informing our crop yield or even a disease level, it's really how we're looking at it in terms of a gross margin at the end of the season. And so the orange bars are the high input loading, and then the blue bars are the low input loading. And this is sort of looking at using the cost of products and then relative to the untreated. So as you can see, there's actually quite a lot of negative figures here, where actually the use of fungicides is actually associated with higher costs, but it haven't sufficiently been able to improve the yield above that of the untreated. And in fact, the untreated would have sort of ranked in the top half of all the treatments in this year's trial. There's definitely very much a trend that the lower input overall as a group are supporting a much higher or relatively higher gross margin, which I think is for a low disease year with very little relatively low yield response is fairly expected, and sort of aligns with some of our previous work around a similar sort of topic in terms of breaking down and looking at these yield responses. It's a very, very similar picture. I think what was quite nice to look at was, obviously, as I talked about the high inputs, a lot of that has been, so not only have we had high inputs of fungicides, we've also used quite a lot of additional materials, so biostimulants, micronutrients and such like. And what I just thought was quite nice to sort of represent was that we need to understand and be using products that are being cost effective and are bringing us margin back into the crop. So this is, if we just look at all these treatment levels and what we put on the crops, taking out the biostimulants, micronutrients, we suddenly get to a point where actually most of the treatments are now net positive relative to the untreated, and invariably the higher inputs are now beginning to be a little bit more cost effective. We're getting a higher return on our gross margin relative to the untreated. And I think it's not, obviously this isn't explicitly being tested within the field trial. We haven't tested the use of biostimulants, and therefore we haven't entirely determined whether they are added into disease control. But I think it's quite clear that they haven't really added anything cost effectively to any yield increases in this year. And I think it does also slightly question where the position of these types of products might be, whether they are there to be supporting an already high input program, or whether they need to be used as part of a combination with a lower level of fungicide input and support that. So I think that's something that we'll potentially look to move to in the next year or so with this work, rather than necessarily just be pushing, what is a high input? We've pushed a high input by adding additional products, but actually these types of products might be able to be more effective when combined with the lower levels of input that we've discussed. So overall, sort of as a fairly brief summary, actually, 2021 was a year of sort of low yield responses generally across the east. The fungicides did actually overall remain effective at managing the disease that was present, and it did protect crop yields. However, this sort of came at a cost, and the low input levels were sufficient. So an overall program of the low input was £81.60 hectare, the price that we used, versus a high input level of 126.40, and these were therefore generally more cost effective in this year. Keeping a programmed approach is necessary, and you can obviously tailor within this, but actually sticking to the T1, T2, T3 type program is far more important, and putting something on each of these timings is far more important than starting to cut out a timing. By cutting out a timing, you're leaving a gap for disease to come in, whereby there's no protection at all in the crop. Whereas even if you cut down on your input like a T2, which we've shown or suggested really could, in this scenario, would have been a nice strategy to mix and match, you maintain the yield, and therefore, but at a cost-effective point. And that really comes on to a final point where we need to respond and adapt as the season pans out. We're not talking about setting out a position where I'm going to put 2 SDHIs on, I'm going to stick to that. We need to be going out and looking at crops, observing what's going on, looking at weather forecasts, and begin to take a bit more of a hands-on approach back to our fungicide management strategy, so that we are getting the most out of it for the most cost-effective program. And I briefly sort of mentioned next year's work. The plan so far is to repeat this work and look at it, how this type of work and this exact trial will look across different seasons. Different seasons are obviously going to bring different pressures, different disease pressures, and different timings of those disease pressures. So how we manage our inputs in different years is obviously going to bring us different results. I think it will be quite nice to try and test the flexibility of the program, where obviously we've stuck to a low and a high, whereas I think actually showing that you can mix these approaches is quite necessary, and therefore where we can most optimize that ability to be flexible across different seasons. I think we'll almost certainly try and push that low input a little bit harder, push it down a little bit, and make that work a little bit harder for us, depending on the season. So I think that's it. So back to Alex.
Brilliant, thanks, Will. Just a couple of questions on there. I mean, the first one is, what varieties of wheat were in the trial?
Yes, so it was all one variety this year. So it was Gleam. So we've got a fairly robust variety to start with, and I think that's that's a strong message in itself. So we were starting with sort of good first principles. It was quite late drilled due to the autumn, a fairly robust variety. So we're sort of starting from a very good point rather than testing this type of work on a typically dirty variety. We're trying to replicate what growers are doing and what this looks like in a sort of real world situation. We're not fishing for disease, as sometimes can be in fungicide trials. And
I mean, how you say it was late drill, Will? How was it looking sort of into the spring? Was it quite a lush green crop, or was it fairly thin and sparse? Did you imagine quite a bit of disease? Or?
No, it certainly wasn't sparse. It was very even. Biomass was probably, I mean, if I'm honest, it was probably a fairly typical crop. It wasn't overly lush. It wasn't, really well greened up, beyond what we'd have expected that season. But it was, yeah, I think the expectation from looking through the season was that it was always going to be a crop that was fairly easy to manage, I think.
And then, so I mean, from these trials and this season's results, just looking at that yield response, are you saying if you want to, on a low pressure year, if you potentially want to cut a chemical back a bit, potentially remove the STHI and just use a triazole, is the T2 timing to do it? Because it's got the lowest response at flag leaf, or?
I think in this season, I think because of the products that we've ended up, we've used in this trial, I think that low rate of Revistar isn't actually that low. I think that's 0.8, probably somewhere around the sort of the average that would be used. So I think it's more that we've got a fairly active and effective fungicide going on. So is that a low? Is that a managed input? As a low input level, I think that's probably all relative to each farm. I think it goes back to having an appropriate amount of fungicide on at each timing, and I think that probably that low rate of Revistar T2 is the appropriate rate for what we saw in the crop. But no, I think typically really we need to make sure that T2 is really well protecting. It's just that in this year that came where the disease was lowest. It came in early, didn't really get going because of the weather conditions, and therefore the T2 was less at risk. But I think, as I say, repeating that over numerous seasons, the T2 is off. We're protecting the flag leaf. It's the most important one for yield, and that's partially why we've also seen good response from that T3, because that was protecting the flag leaf later as these other diseases came in, and it also kept the crop greener for longer. So we're able to take advantage of that later into the season, and that had a strong effect on yield.
Brilliant, thank you. So I think we're just going to play a video now from Brian from the Strategic Farm East, just to gather his thoughts on the trial and take home messages, really. I mean, it's only a short 3-minute video, but Naya, if you could play the video.
So with the lowering input trial where we've been breaking down into high and low investments between the tea timings throughout the season. It's been a really interesting one from my perspective to see how low I could go, but also if I was actually missing a trick by not investing more in the crops that we're growing. Last year we had really big biomass going in, so we were thinking that disease was going to be rife, that there's going to be lots of relief rub, there's going to be a humid crop profile which is going to stimulate disease, and so we thought there'd be a bigger disparity between the low and the high. And it's been quite interesting as the results came through and we were looking at the disease scoring, and especially the untreated. The untreated actually yielded average, I think it was about 9.6 tonne, and that only just obviously had fertiliser and had anything through the sprayer. So that was quite an eye-opener for me. But then you did actually get a bit of payback from investing in more higher investment chemicals, but the net margins at the end of the day will hopefully show that there may have not been that bigger payment for those paybacks, because the disease pressure wasn't as high as we thought. And for me, to see that on the ground, to learn about it on hand in the season as we're looking at it, has again reaffirmed that we need to be much better at monitoring our crops, understanding the disease profile, the disease conditions that we require to actually invest in the crops. And for the second year running, untreated has stacked up very well, but again, I wouldn't want to have my whole farm untreated. It's all about insurance and insuring against the worst case scenario, but my confidence in doing less is growing from the trials that we've been repeating over the last few years. So when I say more monitoring of our crops, we need to be looking at them. I've been doing a lot of plant counts, tiller counts, shoot counts, grain counts all the way through the season. We're obviously using the disease scoring, so looking at the leaf profiles and seeing what level of disease we've had on each leaf layer. And this is what farmers need to really get more involved with, not reliant on just what the agronomists are seeing, but actually going out there and monitoring these crops. And when you're doing a trial like we're promoting with the strategic farm, we say to anyone who comes or wants to know more, go and try it for yourselves. And this is where I think farmers need to do just one field, a couple of tram lines, do one mix in one mix in another, or a different variety, have some untreated plots dotted around the farm, and then actually go and make a conscious effort to go and have a look and make sure that you're seeing what has had nothing compared to what's had your full treatment up to that date. And this really does give you a way of focusing your mind to actually knowing where you're getting the payback. Is it at a well invested T1 or a well invested T2, or is leaving it in the dry seasons best all the way through so the plant gets natural defences up and then only catch any late disease with a T3, so which we did a couple of years ago. So there's lots of ways to do it, but all I can say is go and try it, take a field, be brave, big plot of untreated, or invest higher, try a more expensive program just to see if you are better off, or if your actual program, your resilience you're trying to build on your farm is actually working in your favour.
Brilliant. Sorry about the echo there. I think one of the mics was unmuted, but I think you got the gist of it. The recording will be available on, we'll add this into the recording so you'll be able to view it again if you wish. But I think the main thing Brian was getting across there is to encourage everyone to go out and monitor crops yourself. So I just wondered if Will, I mean, how much would you encourage growers to go out there and monitor their crops, and how important is it to get a feel yourself of sort of what these sprays are doing?
Thank you very much. Yeah, I can't echo what Brian's advocating there enough, really. I think it really is about understanding what you've done and then how that has changed what you're seeing in your fields. You're going to have different fields, different varieties, so you're not going to be growing a single variety across the farm, or you're unlikely to be. So looking at how your programs are stacking up in different varieties is also really important. And that's sometimes as easy as just going putting a tram line in the field over the road versus, you know, switching a tram line over, so you can more effectively manage and check that. And it's about checking what you are doing and just confirming the results of what you're doing, and therefore giving you an opportunity to tweak as you go along in the season. So yeah, definitely get out there. There's some really handy guides. Obviously AHDB have them, and they're rife for sort of disease monitoring, so you know what you're looking at, and then you can really begin to get a better handle on what and how you're going to manage your crop.
Yeah, no, I'd second that. There's plenty of resources, you know, available on the AHDB website or YouTube page, but to be honest, you know, if anything, just have a rough look, isn't it? It's, you know, okay, this one didn't have any chemical, and it's rife with disease, whereas this one had a, you know, pretty bog standard fungicide program. It's managed it a lot better, and it just gives you that confidence as well when you're paying that money for that spray. It's, you know, it's like, okay, it is actually doing something. So yeah, brilliant. So yeah, that's Strategic Farm East. We'll come back at the end with a questions and answers for any questions we didn't answer. But yeah, we'll now go on to Strategic Farm West. Rob Fox at Leamington Spa on the variety side of things, and Chloe Morgan will be sharing the results from ADAS. Thank you.
Thanks, Alex. Yeah, so my name's Chloe Morgan, and I'm a plant pathologist based at ADAS. I'm based at Rosemond over in the west. And so I managed the trial at Rob Fox's, looking at reducing inputs on farm through fungicide use and varieties. So the aim of this trial was really to determine the effect of reduced fungicide applications in varieties with different disease ratings, using high, medium and low fungicide inputs. We're quite lucky in that at the moment we've got quite a few varieties on the recommended list that have high resistance ratings for the key foliar pathogens, yellow rust, septoria and brown rust. So there's a few listed here, should pop up. So we've got X-Days, Prince, Illuminate, Merit, Astronomer and Theodore, which on the 21-22 recommended list all had ratings of 7 or above for those key pathogens. Obviously, we'll also have, as they've got quite good resistance ratings, they've got a higher untreated grain yield. So growing these varieties will reduce the risk of you having a damaging epidemic within your crop and reduce that risk of yield loss. But what I think is still to be understood is how we should treat these varieties, what sort of fungicide level is appropriate in a variety that's already reducing your disease levels. And so what we try to answer that in this trial. So we'll briefly mention some of the conditions that we saw this season, and just to sort of touch on that and explain what it meant for disease conditions in the West. You can see in April, these are the Met Office anomaly charts showing the mean temperature on the left and the rainfall on the right compared to the long-term average. April, as discussed, was quite cold, colder than normal. We saw quite a lot of frosts. It was also very dry, so you can see a lot of the UK had less than 20% of the average rainfall, those dark brown areas. So really dry, a really dry month and a dry start to the season. What this meant for disease, well, for septoria, the disease is spread through the crop by rainfall, splashing the spores up the crop. So a lack of rainfall during this month essentially meant that any septoria that had infested the crop over the winter stayed on those lower leaves and didn't really move from there. Equally, low temperatures will slow down the life cycle of the pathogen. As well, for yellow rust, temperature is important, so a warm spring will generally promote yellow rust, and increased number of frosts can help to control it. So initially, I think we did see some yellow rust, but it did seem to die down during April as a result of frosts. Went through into May, and again, still quite cold, but a lot more rainfall in May. You can see some areas of the UK there receiving more than 200% of their average rainfall for May. And we've not seen a wet May for a long time, I'd say. And rainfall in May is really key for septoria. As I said, it will splash those spores up the crop onto those top 3 newly emerged yield-forming leaves. So the earlier those leaves get disease, obviously the bigger the impact on yield. So in the west of the UK, what that meant was through most of the season, disease levels were low. Prior to T1, very low levels of septoria. Even prior to T2, despite the rainfall levels, were still looking quite low. But as we got towards the end of June and into July, and we started to see the effect of that rainfall, even in treated crops, I think we saw high levels of septoria, really challenging fungicide programs and testing the persistence of the T2 application. So in terms of the trial that we had at Strategic Farm West, 2 varieties were drilled in the field. We just split the field in half and drilled X days in one half and Siskin in the other half. So in terms of disease profile, X days is quite resistant against most of the foliar pathogens with scores of 7 and 8, slightly weaker on eye spot. Siskin, I'd say, is probably moderately resistant. It's a bit more susceptible to septoria with a 6.5 and brown rust rating of 5, but 9 for yellow rust, and eye spot and fusarium blight both being 5s. So both grown commercially, and you can see the untreated grain yield there for X days is higher given that it's got better disease resistance. Overall, the treated grain yields are very similar for the 2 varieties. Within each of those variety blocks, we then applied 3 different fungicide programs to the different tram lines, and these were replicated with 3 tram lines of each treatment in each variety. So we had treatment 1 was a high input program, treatment 2 a medium input, and treatment 3 a low input. And then we also had a block of each variety that we kept untreated, just a small block, to give us an indication of what disease levels were like in the absence of fungicides and what our fungicides were giving us in terms of disease control. So T1 was applied on the 26th of April. The high input received Ascra Expro at 0.8. The medium, we went lower input with tebuconazole and Folpet, so sort of quite a protectant program against yellow rust and septoria. And at this point, there was no disease in the crop, so Rob decided to leave the low input untreated, given that it had been so dry in April. T2 application, obviously 26th of May, so this was after we'd had a lot of rainfall in May. As a result, Rob decided that he would apply Revastar XE at 0.9 litre per hectare across all treatments, just to protect them all really from that disease threat, given the rainfall we'd received. As the aim of this was to try and see how low we could go without damaging yield. So he wanted to protect that yield with a strong T2 program. And then at T3, applied on the 10th of June, the high input and the medium both had TEB at 0.7, and then the low input was again left untreated. So what we're looking at here is the low input was a T2 only program, and we're comparing it really to the high and medium input programs. So the results, we did some measurements on biomass and disease, and I'll just show you some of the key results that we collected. So we did do some NDVI assessments in the field, but these are some images taken from satellite data. So you can see on the left, the image taken from the 27th of December. It does show that at this stage, X days had higher NDVI generally than Siskin on the sort of top left side of the field. When we then go to the 31st of May, however, it looks slightly different with perhaps Siskin, you might say, having higher NDVI. It's not surprising, initially X days was ahead of Siskin in terms of growth stage, which explains that earlier result. But obviously, varieties differ in their canopy sizes and leaf area and ear size. So yeah, you'll see differences later in the season. What these images also show is some variation within the field. There is a bit of soil variation, which we need to bear in mind when looking at the results, as you can see. So for disease, we assess disease every 2 weeks once we started to see more than 5% on the top 3 leaf layers. So this assessment's from the 8th of July, and we're looking at septoria here. We did see low levels of yellow rust and brown rust towards the end of the season in the untreated, but these were controlled quite well with all fungicide treatments. So septoria was really the dominant disease. We did look for eye spot and fusarium, but again, these were quite low. So yeah, Septoria was dominant in this trial. You can see we got quite high levels in the siskin, which was more susceptible, with 90% of the leaf area affected by Septoria on leaf 3 by the 8th of July. In comparison, X-Days did a good job at reducing that level of disease, with 30% in the untreated. The fungicide programs in both varieties did achieve a reduction in disease compared to the untreated, but between 3 different fungicide programs, differences were pretty small, no clear trend between the 3. And a similar result when we look at leaf 2 Septoria on the 15th of July, getting better control from our fungicides on this leaf, with quite substantial reductions in the amount of disease. Although we didn't look at the untreated yield, looking at this data, it's quite safe to say that our fungicides would have improved yield compared to the untreated. Again, X-Days had less disease than the siskin, but when looking at the fungicide programs, not much between them. The low perhaps has slightly more disease in the siskin, but those differences are minimal. So this shows that in terms of disease control, actually in the season, under what was quite a late season disease increase in Septoria, the T2 program only was sufficient in controlling that level of disease in these varieties, which have fairly good resistance ratings. So in terms of yield, we collected the yield map from the farm, and we've got some software called agronomics, which we've developed for looking at serial yield maps. It contains software to clean, process and analyse yield map data, and also has statistics to model the treatment effect after trying to take into account some underlying variation. So we ran the yield map through our software. Here you can see the yield map from the field. You can see on the left the X-Days does appear to be yielding higher than the right-hand side, the siskin, with bigger, more green areas, blue areas. And that was what we found in our analysis. The X-Days yielded 10.29 tonnes per hectare, which was 0.465 tonnes per hectare more than siskin. However, I think due to the variation in the field, this wasn't found to be statistically significant. We needed to be more than 0.6 to be confident in that result. But I think that really follows what we've seen in that siskin had higher disease levels, even in the high input program. So yeah, as a result, X-Days yielded higher. When we then modelled the effect of the fungicide treatments, so we looked at the effect of the high and low input compared to the medium. So in X-Days, the mean yield for medium input strategy was 10.3 tonnes per hectare. When compared to the high input strategy, the high actually yielded slightly lower with a minus 0.3 tonnes per hectare, and the low yielded slightly higher by 0.3 tonnes per hectare. I don't think this is a true result, and I think it has been impacted by the variation in the field, possibly giving us bigger differences than the treatments themselves. So essentially there were no significant differences between the 3 programs, suggesting that the T2 only program was sufficient for yield as well. Equally in siskin, the mean yield for the medium program was 9.1 tonnes per hectare. The high input compared to the medium did decrease yield slightly by 0.3 tonnes per hectare, and there was also a slight decrease for the low input strategy. But again, these weren't statistically significant, so we can say that all programs were comparable in terms of yield. So what this shows is that in both varieties, despite it being a high pressure season, given that it was quite a late epidemic, T2 only program was sufficient for disease control and yield, and there is some capacity in these such varieties to reduce fungicide inputs. Also, selecting varieties with high resistance ratings for disease reduces the risk of a damaging epidemic and reduces the risk of high yield loss. So it's important to tailor your fungicide programs to your variety, lowering your fungicide inputs in crops that are lower risk in order to reduce fungicide use. Also important to know, what diseases are a problem in your area, or weaknesses for your variety. Obviously, a T2 only strategy could work quite well and give you a high margin, or it could be quite a risky strategy, particularly where you've got eye spot or yellow rust. So it's important to know, what risks you've got in your crop. But in reducing fungicide use based on our variety and the season, then we can help to preserve the efficacy of existing fungicides and maximise margins. Thank you very much.
Brilliant. Thanks, Chloe. Just one question. I mean, so if you're selecting a variety for the season from the recommended list, I guess how far up the scale should disease resistance selection be sort of on your mind? Obviously, you need a variety that will meet the market requirements, but should we be selecting varieties with a higher disease rating over a variety that potentially has a little bit higher yield? Go for the lower one, go for the lower yield, let's say, with a higher disease rating.
Yeah, I think you would be better off to choose variety, and it should be quite an important consideration in terms of resistance rating. Obviously, a variety with a lower resistance rating is going to give you more risk of you losing that yield, and than a variety that's got a higher resistance rating. And also, you will have to spend more money on it to keep hold of that yield than a variety that's going to, do most of the work for you.
Very true. Yeah. Brilliant. Thank you, Chloe, for that. Like I say, we'll come to another Q&A at the end, but for now, I think we'll hand over to Steve Howd from SRUC, who will be going through the strategic farm results from Scotland. So, Steve, over to you.
Thanks very much, Alex. I hope everyone can see the screen, and good afternoon, everyone. So as Alex says, I'm going to present some of the results from the Scottish strategic farm, and I've just listed here on the heading my colleagues involved in the project. So Alex has already introduced the strategic farms. I've just got a little bit more information here. So we've got Johnny Balfour, the managing partner, David Agland, the farm manager we work closely with, and then just a little bit more on the cropping system and I suppose what we regard as the overall philosophy of the farm, diversity within the farm in the crop rotation, and then the overarching drive towards what we regard as regenerative agriculture in terms of the way we use inputs and care for the landscape. This is the project team, and here what I'm actually doing as well is introducing the different streams of work that we did in this first year. So this past harvest, we were really gearing up towards baselining several fields for future work. So we had soil health with Joanna and Christine, crop health led by Fiona Burnett, pests and natural enemies led by Lorna Cole, and I covered the crop nutrition area. So what I will do now, I'll just spend a few minutes going through some of the highlights from each of the areas of work, and then I'll say a little bit more about crop nutrition in the second half of the presentation. So on the soils, we made quite a strong link with the AHDB initiative, the Great Soils Partnership, in the way that soils were assessed in terms of their chemistry, their physical properties, and their biology. So the photograph here is one of the ways we were looking at soil structure according to the visual assessment guide that is now widely used in practice. I think overall the soils that we looked at, they tended to be sort of firm to compact in their quality rather than sort of firm to friable. So there is some scope for some improvement there that we think can have benefits for the way that crops can utilize nitrogen, but also the efficiency of nutrient use on farm. So the bullet points there just flag up one or two of the other highlights in this area relating soil quality to earthworm number, and also having some strong evidence that we can link parts of fields or differences between fields to the way we think of more precision application of nutrient inputs. This is the kind of scheme that our colleagues were developing, so using this sort of color code guide here. So there's a lot here. We've got 5 fields highlighted at the top, and then on the left-hand side, we've got some of the chemistry and then some of the physical features that we looked at. So just flag up a couple here. So we've got the potential mineralizable nitrogen there across the different fields. That can be quite useful then coming into adjusting fertilizer management during spring. And then the best refers to the soil assessment guide. And you can see there on the scale from 1 to 5, so 1 being good, we were more towards that kind of firm to compacted rather than at the sort of the intact and friable end. So on to plant health now. So here we monitored the same number of fields, the same fields as the soil assessment, the soil baselining. So the idea here was to match closely with the way that the crop can be maintained through optimal nutrition and then also optimal management for disease control. And that was particularly the case in the winter wheat field that I'll refer to in a moment. So we were linking assessments of crop disease through other measures, both on the ground, but also more remotely here. And so you can actually see in this particular field, spring barley field, an illustration of how we were following through the development of biomass. And in other examples, we were looking at measures such as shoot number and green leaf area. I referred to wheat just a moment ago. So this is where we did quite a lot of very intensive work, both in terms of disease. So this is winter wheat, and this is the variety LG skyscraper. And this was the field in which we did our crop nutrition trial. And this particular sort of color image here, you can see on the right-hand side, those blocks, those red blocks of the lower biomass, relate to the untreated parts of tram lines that we use as part of that particular tram line trial. And I'll say a bit more about that in a moment. The key thing in this particular field, particularly with a philosophy of having lower inputs across the farm, was the control of yellow rust. And in fact, it was yellow rust that had quite a strong effect on reducing yield in the untreated crop. On pests and beneficials now, Lorna's work here, 8 fields were evaluated across the farm. And the key thing here was to measure both the pests and then natural enemies, both in field and in the field margin. So that's something I think we can begin to develop as perhaps as a package to advise on how to maintain margin in relation to the particular crops that are grown across the rotation. So this is just an example of the kind of information that Lorna and team were producing here. So this relates to the abundance of ground beetle, and you can see across fields they're color coded for high, intermediate and low, both in the field, which is the upper part of the figure, and then in the margin in the lower part of the figure. So we can begin to try to match this to particular parts of the farm, the crop rotation and other factors. And as Laura found out, it's not just an easy answer in terms of say particular fields or particular previous cropping situations that give us the differences in abundance. It's much more about microclimate and long-term development of fields. This is just another illustration here for parasitic wasps and money spiders. Again, looking at the same approach where we're looking at abundance of these key species. And here, in this case, you can see some variation across the different cropped fields. So on to the nutrition trial now. So as I say, this was carried out on winter wheat in a field called Tank Wilson's Marsh with skyscraper. Essentially, we had 3 tram lines. So tram line 1 was untreated with fungicide but had standard nitrogen. Tramline 2 was what we called our standard agronomy program. So that was a kind of relatively high input program for this particular farm. And then Tramline 3 was where we wanted to adjust nutrient, particularly on the micronutrient side. And we had the idea that we would adjust crop protection, but in the end, we kept this untreated with fungicide. So in that sense, it was similar to Tramline 1, but had the additional treatment of micronutrients. So all tramlines, in the end, we maintained at the same level of nitrogen fertilizer. So this was the design. So you can see here, if we look at tramlines 1, 2, and 3, each was divided up into zones. So 36-meter width tramlines, and the zones were more or less sort of squares within each tram line, with a spare tram line number 4 there. Now, of course, this is replicated in terms of the main treatments, but we were able to follow through use of technical replication within the tram lines changes through the season. These were some of the crop measures that we wanted to explore. So we wanted to try to develop protocols this year so that we could then decide what would be most useful to use in subsequent years on this farm and other farms. So familiar measures, ground cover, green leaf area, and a suite of different analytical tests, both in the lab and in the field, including the measurement of bricks unit. I'll explain what that is in a moment. So essentially what this is doing is measuring a solute or sugar concentration within leaf tissues. So it's a methodology that we think can be applied to as a guide to the plant's health status. The idea is that we can use this kind of measure to actually indicate the need to apply particular amendments for both nutrients, but potentially also for crop protection. So key part of the project, or this approach to the project, is to validate this kind of approach. So this is the test that we used from some kit at SIUC, where we were taking a sap sample and putting it into the little window, the little cell here, the refractometer cell, to get a bricks value. Now we'll be utilising different refractometers in the coming season just to get a feel for what is most practical and informative to use in practice. This is just to flag up some of the measurements that we did during the season, sort of plant counts, capturing images to look at ground cover, green leaf area index, for example, across the different tram lines. So the idea being that we could try to match these particular measures with some of the lab and the field-based chemical analysis that we were doing as well. We did some testing of methods. Some was in the lab, some was in the field, just to see how measures such as bricks related to the more conventional methods, such as the Spadley readings, because potentially both of these kind of methods can be utilised through technologies such as remote sensing. So we really wanted to get a feel for how these particular methods might relate to each other. We did a lot of chemical analysis, including leaf sap analysis. And I know that this is quite a busy slide here. It's really just illustrating that we did a lot of tests quite frequently. But the concern here is that we still have quite a slow turnaround time with this kind of measure. So it may be the measures that we can do directly in the field and report immediately that are going to be most valued. Overall, I would say from the SAP tests that had a turnaround time of several days, perhaps to about a week, the Tramline 3 was probably closest overall to an optimal balance in terms of the nutrients within leaves. And here's just a summary of the bricks measurements from mid-tillering through to ear emergence there, so from mid-March towards mid-June, and you can see there it's quite noisy in terms of the points, but certainly earlier on in the season the Brix measures tended to be higher than towards the end of the season, and we want to find out what the basis of that is. But there was certainly some evidence early on that the more sort of tailored micronutrient approach in the Tramline 3 had for several weeks higher Brix readings than the other two tramlines. But we really want to kind of tease this out a little bit more to find what was the underlying cause of this. Just to finish now, just with some numbers that relate to the farm bench data. So here you can see the yields between the untreated, the standard agronomy, and then the tailored agronomy, which essentially had micronutrients added, but we actually kept untreated with fungicide. So you can actually see quite a big fungicide effect there, where the standard was 29 to 35% higher yielding. So that's really quite striking. And whereas something like a variety like LG Skyscraper, we might perhaps suspect sort of a 20-25% difference. Grain nitrogens, again, we're thinking of dilution effects here. We can see the grain nitrogen differences that make sense there when we think of the difference, say, between standard and tailored or untreated. And then that's then also, of course, reflected in the N offtake that comes up in the crop as well. So just looking at various inputs and towards efficiencies. So the fertilizer, the same across the tram lines. Then I've got the cost spent on nutrients, crop protection, and then the total costs. So you can see that the nutrient costs, the difference there between the standard and tailored and untreated was very much down to the differences in the micronutrients. And then the crop protection was much less in the untreated and tailored, where that was mainly because of the herbicide input. Then if we just look at the numbers then at the end in terms of margin in relation to yield and those costs, you can see that under these conditions, where certainly the standard coped much better with what became quite a devastating effect of yellow rust, you can see that there were benefits there in terms of the margin for that particular treatment combination. I've got a couple of efficiencies there in terms of nitrogen use, as sort of like approximately for nitrogen use efficiency there, sort of grain yield per unit of fertilizer. So you can see just through the increased yield in the standard that's higher than the other two tram lines. And then we can think about the grain nitrogen offtake in terms of the fertilizer input, and again that was higher in this case in the standard compared to the other two tram lines. Where we did get a difference in terms of some of the costs was, for example, when we think of, say, yield in terms of the spend on crop protection. So we can see a different story emerging there. But then the final two rows there, we can then think of yield per ton of spend or cost per ton, and that they worked out fairly similar across the tram lines. I think the message here is that we can probably take the tailored approach, and actually to benefit from that nitrogen uptake, we could have perhaps protected that just a little bit more, and I think we would have benefited significantly in terms of the yield and potentially the quality of that crop. So just to finish then, here the highlights from the soils, as I mentioned before. The key thing is making use of the scorecard type approach, so we can look at about the chemistry, the biology, and the physical properties of the soils. And we think that certainly from our early work on this farm, we think there is real scope for making some amendments to the field, some changes to the field, so that we can actually make nutrient use and crop health much improved across both the fields that were spring crop this year and winter crops this year. Pests and beneficials here. I think the key thing really is about comparing the field and the margin effect in terms of the insects and beneficials. And certainly something that came up is that we may have sort of complementary behaviour within our natural enemies that one can sort of cover for another in a sense across the diverse farm rotation. On plant health, in a low disease pressure year, we think that the very low input system can be quite effective, but in a season like this season, certainly yellow rust had quite a devastating effect, hence that huge yield penalty that we saw in the benchmark data. So on yellow rust itself, we think that a key message here is that we're following this through as early as autumn into early spring towards that T1 stage, where we think timing can be crucial for this disease. And then overall, as Chloe would have said, it's really about bringing a number of factors together under sort of the IPM or ICM approach in terms of the way we think of health and nutrition. Just quickly then on nutrition, we've developed a number of protocols that we hope to apply more widely in year 2 and beyond. And as well as this farm, what we do on this farm, we want to be able to try and test things elsewhere. And ultimately, what we want to do is link some of our ground measures to other technologies, such as remote sensing. And then just to finish, what we hope to do next year with the real development of the nutrition area, more detailed work on nitrogen and other aspects of nutrition, but also introducing the idea of pre-cropping or cover crops before spring barley and having a much closer look at spring barley establishment. Okay, Alex, thanks very much.
Brilliant, thanks, Steve. Just a question from me, really. I mean, you mentioned about plans for 2021-22 in developing the nutrition trial. I mean, how, I guess what went well, after doing it for a year, I guess what went well and what didn't go so well, and then what aspects are you taking into next year?
Yeah, what was interesting, I suppose, with our tramline treatments, it was kind of it was evolving during the season in some ways. So what we'd probably like to do is to have perhaps a little bit more precision and differentiation between some major sort of tramline or treatment effects. So I think sort of a blend of some of the approaches that we use this year. We want to look much more closely at the interplay between the crop protection and nutrition. So that's why we've got those two particular elements here. So it's really trying to tease out some of those things I try to show from the benchmark data, because there's obviously things going on there where we think we've got a micronutrient effect that was very positive, but we want to tease that out and actually see whether we can pick that up through our crop measuring during the early spring in particular.
And how are the bricks measurements sampled across the treatments, and how will you respond to these data in season?
Yeah, so that's a good point, because of course it's something that you go into the field with a handheld device and make a measure. So we actually did it in this particular crop nutrition trial based on the zones within the tram lines. So now we really need to be able to advise on how many measures we should make within a field or part of a field. And ultimately, I think it's a bit like field walking and traditional disease assessment. We want to be able to try to link these to more advanced technologies such as remote sensing. So I think what we all spend a bit of time perhaps optimizing the number of measures that we need to take, particularly where we sense that there are perhaps inherent differences within fields anyway. So we want to see whether there are natural sort of field gradients that might impact on those measurements. And we can tie that to some extent with other measures such as SPAD readings and some of this sort of routine nutrient analysis that we do. But as I say, some of the nutrient analysis can be slow to turn around, and certainly during the periods of rapid crop growth, they're perhaps not as speedy enough.
Brilliant. And then yeah, so I think we'll finish off with a few questions now. So if for everyone, so if we get Will and Chloe back on the screen, and yeah, we'll just keep our cameras on, I think, just for now, and then I'll just finish off with a few slides. But I mean, I'd like to ask a question. I mean, you know, so if I'm a grower wanting to get started on cutting back on fungicides, but you know, I'm worried about my crop completely failing or being overcome with disease, I guess, where do I start? Is it variety selection? Is it cutting out the tina or potentially, or cutting back on the chemical, or is it making the plant strong and healthy? I mean, I guess you might say it's all three, but I guess, Will, if you could have a go at that one, you know, where do you start as such?
Yeah, I think giving yourself the strongest possible base. So that is, I think Steve mentioned the principles of IPM. So slightly later drilling date, and choosing a suitable variety, something that has a high untreated yield. Look using the RL tool, something that maybe might not need as much management as a starting point. I think from there it is a case of just slightly reducing the amount that you're putting on at each timing. I think, I mean, T0 maybe is an exception, but certainly of those main timings, I wouldn't be recommending that people are cutting them out entirely without repeating exactly what I've just been talking about. But the idea that, you know, cutting out entire timings, I think, is probably reckless, but managing those from what you're seeing in the crop is the best way to go. But starting from that strong variety base is certainly the first step. So it all starts in the autumn. It's not about deciding in March, oh, I'm going to lower my inputs. You need to be thinking about it, you know, August, September time.
Brilliant. And another question: does cutting down doses actually do more harm than good in the long run for fungicide resistance?
I'd probably put you under Chloe for that.
Chloe, you know.
I think it's all about appropriate dose, because obviously, if you're not using the appropriate amount of dose, then you're exposing septoid blood spores to that chemistry, and it's surviving, and it's then able to mutate. But equally, if you're over applying, then again, especially particularly if you're using one fungicide in particular, you're exposing the population to that particular fungicide more and more, and again, it learns to overcome it. So I think it's all about using an appropriate dose for the level of disease that you're seeing in your crop, and also using mixtures to protect that fungicide. So using multisites, for example, and again, using more resistant varieties is also going to help, because it's reducing the burden that fungicide's got to act on. So yeah, using all three methods really in an IPM approach is the way forward.
Good. Probably another one for you, Chloe. Having seen the likes of Saki and Firefly's genetics succumb to Septoria this year, is it fair to put increased pressure on very limited variety genetics to decrease spend on other inputs?
That's a good question. Generally, the resistance, I appreciate these have happened quite quickly. Those varieties with Cougarin have suddenly gone, and quite a big shift. Generally, the resistance to Septoria does take a bit longer to slide. I think it is a case of, yeah, there's a lot of varieties out there now that do have strong resistance ratings. It's not a case, there's not just one variety on the list. I think people are growing a range depending on where they're located in the country and what they're growing. And I think it's worth taking advantage of these, because if we were all to grow susceptible varieties, then we'd equally be putting pressure on our chemistry. So using the two together, using the chemistry to protect the varieties and the varieties to protect the chemistry, essentially, is the only way to keep hold of them both for the long term.
Brilliant. One for Steve. What was the date of the skyscraper drilling data, Balvernie? Was it quite late?
Yeah, I think that was early October, so it wasn't too early. Yes, but I'll try and find the date for you, but I think it was early October.
Brilliant. And then, well, if you repeat the trial, your trial next year, should you, or how are you going to approach, or should you remove the influence of micronutrients / biostimulants, or at least put them in a different treatment to allow you to sort of measure that impact of them?
Yeah, I think it'd be something to discuss with Brian. Exactly how we manage that. I think we want to keep on a field scale, so we are sort of limited by the number of treatments. We don't have sort of an unlimited field to work in, so I think splitting them out entirely would be difficult. Whether we can add them in as sort of like a higher input plus, so we can have a single treatment that is that, or you know, or a low input plus kind of thing. So I think there's something we can do to try and pull out the differences there without going through a full trial of just looking at biostimulants.
Brilliant, thank you. Well, I think that comes to the end of the questions now. I'll just attempt to share my screen. So yeah, just before you all go, so these results and findings are based off our strategic farms, which is part of our sort of farm excellence platform, and this is just outlining a presence in sort of the majority of areas. So hopefully there's one near you that you can get yourself down to in the summer or these winter meeting, you know, and you can get to see it in field. And this is the team in charge of the Farm Excellence platform. As you can see, Philip Dolbear is also covering Southwest as well as East Anglia. So we're actually recruiting in East Anglia and in Scotland, but it's about getting the right person, you know, in the right area. And keeping in touch with anything strategic farm. So what we've been talking about today, these are the go-to people. So Emily Pope and Fiona Geary. Fiona Geary was chairing yesterday, and as we go forward, she'll be the main contact. Included in this Farm Excellent platform is also our sort of regional monitor farm program. You know, that's a scaled down version of strategic farms. You know, doing on tryouts and a host of winter meetings on particular topics like carbon, regen ag, things like that. So you know, to book onto any of these events, whether it be the strategic farms, the conferences, or the monitor farm programs, you know, just visit the AHDB website. There's a tab at the top there, events, and just click that tab, and you scroll down to find your preferred location. As I mentioned, conferences, the future agronomy dates to make aware of. I know there's a few agronomists on the call today, so we have our National Agronomist Conference on the 7th of December. And if you can't make that, we also have our regional specific agronomy conferences, and there's a whole host of dates there, but again, they're on the website. So upcoming this week, tomorrow's agenda, we've obviously had Monday and Tuesday, insecticides on Monday and lowering inputs on Tuesday, and on Wednesday we've got can cover and catch crops help create a more profitable enterprise, and really diving into the costs and the benefits, you know, side of things, and working out if they really do stack up, because that's a big question. And of course, you know, if you missed any of the sessions this week, they will be available in the coming days on the AHDB Cereals and Oilseeds YouTube page. And the full reports from these trials we've just talked about are actually available on the website now, on the Strategic Farm website. So that just leaves me to say, I mean, thank you to all the speakers today. I think you've done a brilliant job. And thank you to those who watched the webinar. You know, I hope you gained some value and it's made you question certain things about your own inputs and, you know, what you might try next year, whether it be get out and looking at disease and seeing what the sprays do, or just cutting back and seeing, you know, how that impacts yield, or if it does or it doesn't, you know. So that leaves me to say, sort of, the webinar will end by itself. So attendees and speakers, you don't have to do anything. It'll just close down. And with that being said, I hope you have a good rest of the day, and hopefully we'll see you in the next one. Thank you.